Hi everyone. Here we are going to discuss one of the most important concepts from the chapter Chemical Bonding and Molecular Structure, Dipole Moment. It's very important concept even for your competitive examination and board examination. Okay, so directly we can go to the topic and some questions. So dipole moment. What is the meaning of dipole moment? Dipole moment is actually a magnitude we are calculating to explain the percentage of ionic character in a covalent compound. You know that there is no compound with 100% covalent and 100% ionic in nature. In a covalent compound, there will be some ionic character. In an ionic compound, there will be some covalent character. We know covalent character we are mainly explained through one of the principles called Fajan's rule, right? Fajan's rule. You know, here we are discussing in dipole moment. In dipole moment, that's meaning that what is the percentage? What is the percentage of ionic character? Ionic character in a covalent compound. In a covalent compound. In a covalent compound. So in a covalent compound, how much percentage of ionic character is present? That's calculated by dipole moment. Dipole moment is represented by the symbol nu. Okay, dipole moment is represented by the symbol nu. Dipole moment is calculated by the equation Q into D, or we'll write R. Q into R or Q into D. What is Q and what is D? Nu represent dipole moment. Q represent the charge. The charge on any one atom. Charge on any atom. Q, D represent the internuclear distance. The internuclear distance means the distance between two nucleus. That's it. So dipole moment you can define as it is the product of charge on any atom into the distance of separation, or we call internuclear distance. Alright, for example, you consider two species. Okay, for example, HF, just one HF. You know, HF molecule when you consider, the internuclear distance mean hydrogen, it's an atom. So the nucleus will be there. Fluorine is an atom, the nucleus will be there. Their nuclear distance is called what? Internuclear distance, that is called D. Q represent charge on an atom. If you consider hydrogen and fluorine, which is the most electronegative element, fluorine is the most electronegative element. So fluorine tried to get a negative charge, a partial negative, delta negative charge, because fluorine is most electronegative element. Whereas hydrogen carry a partial positive charge, correct? So why this charge separation happen? Because of their difference in electronegativity. Clear all of you? Okay. So this is called dipole moment. So dipole moment nu is equal to Q into D. One more data. If a compound having a net dipole moment, if a compound having a net dipole moment, we can say that the compound is polar. If a compound having a net dipole moment, you can call the compound is polar. Whereas, if the net dipole moment is equal to 0, if it is 0, then you can say that the compound is non-polar. Okay, non-polar. We can go to the topic. First, I am discussing about in homoatomic molecule. Homo means the same molecule. For example, you consider hydrogen, H2 molecule, fluorine molecule, chlorine molecule. In this kind of system, you can able to understand that H2 molecule you can represent like this one, right? HH, right? HH. Here it is FF. Here it is what? Chlorine and chlorine. All right. So HH when you consider, is there any difference in their electronegativity? No, because both are same element. Fluorine when you consider, no change in electronegativity. Chlorine means homoatomic species, if they have their dipole moment is equal to 0, dipole moment in this kind of system, dipole moment is 0, or you can say that these systems are non-polar molecule. Okay, so homoatomic molecules, when you consider, they are non-polar species. Why? Because there is no change in electronegativity nor charge separation, right? Therefore, their homoatomic molecule dipole moment is 0. Homoatomic molecules are non-polar molecules. What about in heteroatomic molecule? Means they are different species. For example, you can consider HF molecule, all right, HCl molecule, HBr molecule, anything, HI molecule. These all are heteroatoms, right? Hydrogen with the fluorine, different element. In this kind of system, you can able to understand hydrogen and fluorine. When you consider there is 2 electrons between them, fluorine is the most electronegative element, so they will try to take electrons, so they will get a partial negative charge, partial positive charge. Here chlorine is the electronegative element, so partial negative, partial positive, partial negative, partial positive, partial negative, partial positive. Are you clear according to what property we are writing the negative and positive charge? Because of their difference in electronegativity. The electrons try to move from less electronegative elements to more electronegative element. Yes or no? This is the less electronegative element. Less electronegative element, and the electron try to move from less electronegative elements to more electronegative element, right? Always electron try to move from less electronegative element to more electronegative element, correct? So fluorine, chlorine, bromine, iodine, these are the electronegative elements, so the movement of electron will take place like that. Now another system, we are using one of the representation of arrow for expressing dipole moment. The arrow is like this. We will represent like this. What does this arrow represent? This side, the arrow, where it is the arrow projected, that side, your element, it should be more electronegative element. More electronegative element on the arrow side, towards the arrow. And the plus sign, right? Plus sign which represent the less electronegative element. Less electronegative element. Okay, so this is the arrow representation in dipole moment. A plus sign represent where the electronegativity is very less for the element. The arrow represent the element having greater electronegativity. Alright, see all of you here. Hydrogen and fluorine, when you consider which is the most electronegative element, fluorine is the most one, so we can draw like this. Means hydrogen carry a positive charge, correct? Hydrogen and chlorine, when you consider hydrogen to chlorine, hydrogen to bromine, hydrogen to iodine, this is the situation, correct? So all of them having a dipole moment. So dipole moment, as I told you, we are using the equation Q into D. But here actually we are not calculating, we are not making any numerical calculation. This is just something doing a dipole moment, a net dipole moment is there or not. Okay, we are not doing any numerical. You know, dipole moment is a vector quantity. It's having a magnitude as well as a direction. We are just calculating if there is a net resultant or not. Let me show you through maximum example. So, these are the system. So, HF, HCl, HBr, HI having a net dipole moment. So, we can say the compound all are polar. These all are polar molecules. So heteroatoms are generally polar molecule, not all, and homoatomic molecules are generally non-polar molecule. Now, suppose you are asking the question whether HF, HCl, HBr, HI, when you consider which one having most dipole moment, which one having more dipole moment, what we can say here. All of you please observe, HF, HCl, HBr, HI, when you consider the dipole moment is mainly depends on charge on the atom and internuclear distance, right? So charge increases, dipole moment increases. The internuclear distance increases, dipole moment increases, correct? Okay. So here HF, HCl, HBr, HI, when you consider which one having greater charge, you know, fluorine is the most electronegative element, correct? So fluorine having greater charge. So we can say first one, second one, third one, fourth one, when you consider, we can say that first one having greater electronegativity means greater charge. So we can say first, second, third, fourth, this will be the order. Yes or no? It having greater dipole moment because charge is greater for fluorine. What about when you consider the factor D, internuclear distance? Which one having greater internuclear distance? You know, fluorine is a smaller element, chlorine is little bigger, bromine again bigger, iodine is again bigger. Where is the internuclear distance greater? In iodine. So iodine having greater dipole moment when you consider as an internuclear distance as a factor. So we can say fourth one, third one, second one, and then we have first one. Then the confusion all together, which one having greater dipole moment? When charge and this internuclear distance, when you consider the highest priority we have to give for charge, dear all of you. Okay, charge. One exception is there, I will tell you in the final case. So charge is the main factor. So we have to consider HF having greater dipole moment than HCl, HBr, HI. This is the correct order. Clear? Now let us discuss about polyatomic molecule. These are diatomic molecule, only 2 atoms. Let us discuss. Mostly they will focus on polyatomic molecule. How can we identify the dipole moment? Let's see one by one. I'm going to the question for the system BeCl2. One more thing. We already did or studied VSEPR theory, how to find the geometry of a molecule. Right? You know how to find out the geometry of a molecule. If you know the proper geometry of a molecule, then only we can able to answer the dipole moment. It having a dipole moment or not. Alright. So once again, I'm repeating, those compounds having a dipole moment, we can call it as polar molecule. Those compounds dipole moment is 0, they are called non-polar molecule. Clear? Okay. BeCl2, which is the central atom, beryllium. Alright, beryllium. Cl2, which means 2 chlorines are there. Dear all of you, according to VSEPR theory, what is the geometry of BeCl2? You may study that linear geometry. BeCl2 is a linear molecule. BeCl2 like this. Okay, let's go. Let us calculate the dipole moment. Beryllium is the central atom, right? Chlorine is the surrounded atom. Beryllium and chlorine, when you consider, if you consider the left bond, which is more electronegative, chlorine, right? So the electron shifted towards chlorine, beryllium carry a positive charge. Beryllium and chlorine, here the same way, chlorine is most electronegative element, the arrow represent most electronegative element, towards that electron will move, the other part will get positive charge. Now you see, same elements are located left and right, they are pulling with equal strength in opposite direction. They will cancel each other, right? They will cancel each other, right? So net dipole moment is 0. Their charge finally becomes 0, neutral. So dipole moment, here it is cancelling each other, dipole moment 0. That's why I told you, dipole moment actually is equal to Q into D. Actually, we are not making any numerical calculation. The dipole moment is cancelling, or there is a net dipole moment or not. That's only we are checking, because it's a vector quantity. Dipole moment is a vector quantity. So here beryllium, chlorine, they are pulling in equal strength. The dipole moment is equal to 0. If the dipole moment is 0, we studied that the system is non-polar. Let me tell you one more thing. Generally, if the compound having a linear geometry, okay, here linear geometry. If the compound having a linear geometry in which the surrounded elements are similar, most cases dipole moment will equal, means cancel each other. Dipole moment is 0. Let me show you some other geometry also where we can identify always dipole moment is 0. Okay, see. Another one, carbon dioxide. Carbon dioxide, which is the central atom, you know. Carbon is the central atom surrounded by 2 oxygen atoms. That's also having linear geometry. Dear all of you, carbon and oxygen, when you consider, which is the most electronegative element? Oxygen, right? So the electron move towards oxygen. This is the positive part. Move towards oxygen, positive part. Alright. What do you think? As I told you, if it having a linear geometry, if the surrounded elements are similar, they will pull with equal strength. So the net dipole moment will be 0. So dipole moment is equal to 0. So carbon dioxide is a non-polar molecule. Dear all of you, please consider a individual bond. Okay, you just avoid this one. If you consider a individual bond like a CO, this is polar or non-polar? Yes. because carbon carry a delta plus, oxygen carry delta minus. If you consider the individual bond of CO, it is polar, but the overall compound is non-polar. Clear? Alright. So let's go to the next question. BF3 and BCl3, both of them having same geometry. Let's see. BF3, boron. That's why I told you, dear student, it is compulsory to know the geometry of the molecule, okay? BF3 having trigonal planar geometry. What about BCl3? BCl3 also same geometry, trigonal planar. Let's go for that. BF and boron and fluorine, when you consider, fluorine is the most electronegative element. Here fluorine is the most electronegative element. Fluorine is the most electronegative element. What do you think? The net dipole moment will cancel each other or not? Yes, of course. Because you see, this is the central one. It's pulling like this. All the surrounded elements are equal. They are pulling, right? These all are 120, 120, 120 degree. When they pull with equal strength, all the dipole moment will cancel each other. So here also dipole moment is 0. Therefore, the compound is non-polar. What about BCl3? Same situation. Chlorine is the most electronegative element, right? So what happened? All the dipole moment will cancel each other. Dipole moment is 0. Compound again non-polar. So what you understood from this data? If the geometry is trigonal planar and the surrounded elements are same one, their dipole moment most of the cases will be 0. Because they are pulling with equal strength with a 120 degree equal angle, so they will cancel each other. So the net dipole moment is 0, compound is non-polar. For the system, trigonal planar geometry. Question number 5. SO3 and SO2. Sulfur trioxide and sulfur dioxide. Alright. In sulfur trioxide, dear student, structure is this one. In sulfur dioxide is this is the geometry. Both of them actually having trigonal planar geometry. We studied in the VSE PR theory what is the difference between shape and geometry. What is the shape of this molecule, dear all of you? When you calculating the shape of the molecule, you have to consider both bond pair and lone pair, how they located. Bond pair, lone pair. It's just like a trigonal planar geometry. What is the shape of the molecule? If I'm asking, just to cancel the lone pair, only look into the bond pair, how they located. Bend geometry. Alright, see, we already discussed in one of the video for the VSE PR theory how to calculate the geometry and the shape of the molecule. Correct. So both of them having trigonal planar geometry. As I told you, in a trigonal planar geometry, all the surrounded elements, when they are equal, we can say that their dipole moment will cancel each other. So in which system the dipole moment can cancel each other? Yes, I think first one. Because sulfur and oxygen, when you consider, oxygen is more electronegative, so we can draw like this. So all of the dipole moment will cancel each other and dipole moment is equal to 0. The compound is non-polar. But what about SO2? In SO2, sulfur oxygen consider, no doubts oxygen is the most electronegative. Dear student, lone pair if they given. Keep in mind, lone pair if they given, always you should draw the dipole moment diagram or arrow like this. Okay, lone pair. If you consider a atom and there is a lone pair if it is given, okay, there is an atom. Here sulfur is the atom and a lone pair given. Always you should draw the arrow towards the lone pair. Okay, towards the lone pair. So lone pair upward to oxygen below. What's the situation? Will they cancel? No. All are equal, all are same element like this one, then they will cancel each other. But here, 2 oxygen pulling down, 1 lone pair. Definitely they won't, some cancellation will be there, but there will be a little dipole moment, right? Net resultant is not exactly 0. So we can say it having a dipole moment, so we can say the compound is little polar. But here dipole moment 0, so compound is what? Non-polar. Correct? So very easy to identify whether the compound is completely polar or non-polar by applying the dipole moment concept. But we should know the geometry of the molecule. Okay, next one. Seventh one, methane, CH4. Let me draw the shape CH4. You know, CH4 having a tetrahedral geometry, right? Tetrahedral geometry. CH3F, same thing, okay? CH3F also same geometry. CH3F also same geometry. CHCl3, same geometry, okay? Same geometry, dear all of you. They're having same geometry. All of them having tetrahedral geometry. CH4, CH3F, CH3, CHCl3, all are belongs to which one? Tetrahedral geometry. Let's see in tetrahedral geometry what is the situation. You know, carbon and hydrogen, when you consider, carbon is more electronegative element. So towards carbon we can draw this one. You know, in tetrahedral bond angle, normal tetrahedral bond angle is 109.5 degree or 109 degree 28 minutes. All bond angles are equal in tetrahedral geometry. Okay, so what happened? See, these two hydrogens are giving like this, two hydrogens are giving this, is all of them will cancel each other. In tetrahedral geometry, dipole moment is 0. Therefore, the compound is non-polar. When all the surrounded elements are same. In a tetrahedral geometry, all the surrounded species are similar, their dipole moment will be 0. But you see, this is also tetrahedral, but can be 0 here? No, because all the surrounded elements are not same. Here, one is fluorine, hydrogen, hydrogen, hydrogen. Carbon and fluorine, when you consider, you know, fluorine is most electronegative. Carbon and hydrogen, when you consider, carbon is more electronegative. So we can draw the arrow like this. Dear all of you, see, observe that all the dipole moments are adding up. Correct? All the dipole moments are adding up here. This is the resultant. So it having a resultant means it having a dipole moment. So don't think always tetrahedral geometry means dipole moment is 0. When it will be 0, all the surrounded species are equal, then they will be cancel each other. If they are not same, it having a net dipole moment. All right. What about CHCl3? In CHCl3, carbon, chlorine, when you consider, chlorine is the one. Okay, chlorine is the one. Carbon, hydrogen, when you consider, carbon is the greatest one. Yes, it's also having a net dipole moment downward. Correct or not? So all dipole moments are adding up. So there is a dipole moment. So it is also said to be a polar molecule. Clear all of you the idea? Let's go to the next one. PCl5 and SF6. What is PCl5 geometry? P, Cl, Cl, Cl. You know, PCl5. This is the geometry. Trigonal bipyramidal. Trigonal bipyramidal. That's a geometry of which one? PCl5, phosphorus pentachloride. What about the situation? Let's see. When you consider, when you consider the chlorine in the trigonal planar geometry, okay, this chlorine is the most electronegative element. So chlorine, chlorine. It's just like a trigonal planar, right? We studied already in trigonal planar geometry. If the surrounded species are equal, their dipole moment will be cancel each other. So these three chlorine, their dipole moment 0. What about these two chlorine? One chlorine upward, the other chlorine downward. Yes, they will cancel each other. So PCl5 also dipole moment is 0. Therefore, the compound is what? Non-polar. So another confirmation, you already got it. In a trigonal bipyramidal geometry, if all the surrounded species are equal, then their dipole moment will be 0. Next one, SF6. What is the geometry of SF6? Sorry. Sulfur 1, 2, 3, 4. Square, one fluorine above, one fluorine below. Square bipyramidal or octahedral, right? Square bipyramidal is also called what? Octahedral geometry. Let's see. Fluorine is the most electronegative element, no problem. So fluorine, fluorine. These two fluorine cancel each other. Fluorine, fluorine. They are cancel each other. One fluorine upward, one fluorine downward. That's also cancel each other. Dipole moment is 0, dear. So in octahedral geometry, if the all surrounded species are similar, their dipole moment will be 0. Therefore, they are non-polar. Got it? That's it. Next one. NH3 and H2O. You know, ammonia, nitrogen, This is what? Ammonia. There are 3 bond pair, 1 lone pair. What about water? Okay, this is about water. Alright. So here what you thinking about the dipole moment. When you consider ammonia, you know, nitrogen and hydrogen, when you consider, nitrogen is the most electronegative element. So we can draw the dipole moment arrow like this. And lone pair, I told you, always you should write lone pair towards the lone pair. What about here? Oxygen and hydrogen, when you consider, oxygen is more electronegative, okay? But lone pair always pull towards that, okay? Where is the resultant you have? In ammonia, do you have any resultant? All of them are cancel each other. There is a resultant, right? All are adding up. The resultant is upward. See, all are adding up and the resultant is upward. So we can say ammonia having a dipole moment. Therefore, ammonia is a polar molecule. What about water? These 2 hydrogens are contributing like this. Lone pair is contributing like this. So where is the resultant? Resultant will be upward. If there is a resultant, we will call it having a dipole moment. So water also polar because it having a dipole moment. Hope you clear how to find out the dipole moment for a system if you know the geometry, correct? Okay. Next one. XeF2 and XeF4. Dear student, XeF2 geometry is actually linear geometry, okay, linear one, XeF2 and xenon containing 3 lone pair like this. Linear shape actually. When you're calculating the geometry, we can say trigonal bipyramidal. We can draw in the opposite way like XC, F. Okay, both are same actually. Alright, so in this case, this is actually trigonal bipyramidal. That is a geometry. If you consider the shape of the molecule, I told you lone pair, just avoid it. So therefore linear. Let's see. Lone pair, you know, always towards lone pair, towards lone pair, towards lone pair. You know, it's a trigonal planar. All species are similar. So dipole moment will cancel each other. What about fluorine? Fluorine, one upward, one fluorine downward. So dipole moment is again 0. So the compound is polar or non-polar? Non-polar. XeF4. XeF4 we can draw like this. Xe, F, square over. And 1 lone pair above the plane, 1 lone pair below the plane. What is the geometry? Square bipyramidal. Square bipyramidal, or we will call octahedral geometry. What about the situation here? Fluorine is the most electronegative. Fluorine is most electronegative. They cancel each other. Here or opposite cancel each other. The lone pair I told you always towards that, so they will cancel each other. So in this system also dipole moment is equal to 0. Therefore the compound is what? Non-polar. Next one. Let's go to one of the question regarding your competitive examination. Okay. Which of the following is non-polar molecule? All of you please observe. 1 minute. Can you identify which of the compound is non-polar? We already discussed all the compounds mostly. Yes. Can you identify which compound is non-polar? Hope you get the answer. SO2. What is SO2? We draw the structure like this one. SO2. This is the geometry. Carbon dioxide, CO2, linear geometry. Water, it's having tetrahedral one or bend one. Ammonia, a pyramidal one. Correct? These are the structure. Where we can identify dipole moment 0, then only the system will be non-polar, right? Yes, hope you get the idea. Sulfur, oxygen, when you consider, oxygen is more electronegative, lone pair pull upward. All of the species are not same, so the dipole moment will not cancel each other. So here it having a dipole moment. So this is polar. This is what? Polar. What about carbon dioxide? Carbon oxygen, when you consider oxygen is more electronegative, they are same species, dipole moment will be 0. Yes, dear all of you, carbon dioxide is a non-polar compound. Water and ammonia we already discussed, both are polar. Both are polar because having a net dipole moment. Clear all of you the question? Okay, let's go to the next one. There is an exceptional case we are trying to discuss here. Arrange the following compound in the decreasing order of dipole moment. Okay, what are the species given here? CH3F, methyl fluoride, CH3Cl, methyl chloride, CH3Br, and CH3I, methyl iodide. Okay. Question, dipole moment we have to calculate. We know dipole moment is equal to what? Q into D, charge into internuclear distance. Here the bond actually connected to carbon and fluorine. You know, fluorine is the most electronegative element here. Chlorine is the most here, and bromine and iodine. All right. Actually, all are having dipole moment and all are polar molecule. Among that, which is the most polar molecule? That's a question. Can you identify? As I told you, an exceptional case, but something as experimental value is there. Okay. Anyway, let me tell you. If you consider charge as a factor, because charge increases on the species, on the atom, dipole moment increases. Which one having greater charge? No doubt fluorine, because that is the most electronegative element here. So if you consider charge as a species, we can say the first compound having greater than down the group or down to fluorine to iodine, we can say the dipole moment will decrease. When you consider distance, internuclear distance as a factor, you know, fluorine, chlorine, bromine, iodine. Where is the internuclear distance greater? In iodine? Because iodine having bigger size. When you consider that factor, we are expecting down one having greater dipole moment. But as I told you, this is an experimental data. Greater dipole moment, if you want to know in this concept, just remember all of you, just to switch the first two. That's the order. Just to switch the first two species, which mean CH3Cl having greater, CH3Cl having greater, then CH3F, then remaining same order, CH3Br and CH3I. This is the correct order for their dipole moment. Greater dipole moment is for which one? Methyl chloride. And why? This is actually a experimental determination. The problem is, when you consider charge as a factor, we know that fluorine having greater charge, right? Greater charge. But its size is what? Little less. But when you come to chlorine, its charge is little less. Its internuclear distance is little great. So there is a very big competition between CH3F and CH3Cl. Therefore, as experimentally, when they combine all these factors together, means both charge and distance of separation, like internuclear distance, they confirm that CH3Cl, that's coming first. So mostly in competitive examination, they will focus on experimental data because there is a chance to make some mistakes. So this is one of the experimental one. All of you keep concentrate. When they given methyl fluoride, methyl chloride, methyl bromide, methyl iodide, the methyl chloride and methyl fluoride, just to switch it. That's it. All right. Next one. We can discuss. So we discussed the dipole moment, how to find out in a polar molecule like a homoatomic molecule and heteroatomic molecule and polyatomic molecule. Here we are going to discuss how to calculate the dipole moment in geometrical isomers. You may studied in organic chemistry. Geometrical isomers mean cis and trans isomer. Cis and trans isomer. For one of the example, let me give you C double bond C, and here we have suppose fluorine, chlorine. Simplest element, let's discuss. Hydrogen. Okay, one of the species. C double bond C, fluorine, hydrogen. See, both are isomers, right? Same formula, but different in something. What is the difference? In first case, when you consider the same species, fluorine and fluorine are opposite. That's confirmation is also known as what? Transform. If the same species on the double bonded carbon are on opposite direction, then it is called trans. If the same species are on same side, it is called what? Cis isomer. See, fluorine and fluorine same side, hydrogen same side. Right. Now, here you see, let us calculate the dipole moment. Fluorine and carbon, when you consider, which is the most electronegative element, you know, fluorine is the most electronegative element. We can draw like this. Here also fluorine is the most electron. See, fluorine are opposite. The dipole moment is cancel each other. Carbon and hydrogen, when you consider, carbon is the most electronegative element. Here also carbon, they are also dipole moment cancel each other. So in transform, dipole moment is 0. Not in all cases, almost 90% we can say in transform, if such a situation, if it is there, dipole moment is 0. But not in all compound, because the dipole moment depends on which group present here. Let's show you another example. Let's go to the cis isomer. This is the cis form because the same species are on same side. Fluorine, you know, this is the most electronegative element. We can draw like this. Carbon and hydrogen, when you consider, carbon is the most one. So where is the resultant, all of you? Here it is here, it is here, resultant is upward. If there is a resultant, we will call it having a dipole moment. So generally, cis isomers having dipole moment. So cis isomers are exist as polar molecule, whereas trans isomer having dipole moment 0, so non-polar. But I told you, not always. Let me show you one more example here. All of you carefully listen. C double bond C. Okay, C double bond C. Suppose we have chlorine, chlorine. All right, chlorine, methyl. Here C double bond C, chlorine, methyl. See, all of you. Are you sure this is trans? Yes, the same species are on opposite side. Same species on same side, therefore cis isomer. Let's see. In this case also, carbon, chlorine, when you consider, chlorine is the most electronegative element. So what happened? The dipole moment cancel each other. Because they are same species, they are pulling opposite direction. Here, carbon and carbon, confusion. Both are carbon, right? Both are carbon. Dear all of you, this is a single bonded carbon. This is a double bonded carbon. Double bonded carbons are more electronegative than single bonded carbon. So they will contribute like this. Here it is like this. So dipole moment cancel each other. So in trans isomer again, dipole moment is 0, non-polar. What about cis isomer? Chlorine and chlorine, right? Chlorine is the most electronegative here. Chlorine is the most electronegative here. And single bonded carbon, double bonded carbon, when you consider, double bonded one is the most electronegative. Okay, so it is contributing here, resultant is upward. So it having a dipole moment. So there is again polar molecule. Alright, so in this case, in these two cases, we saw that cis isomers are polar, trans isomers are non-polar because of the cancellation and resultant. Let me show you another exceptional case here. Let us consider C double bond C. Okay, C double bond C here. The substituents, all of you please observe. Chlorine and chlorine. Here I am writing you CH3 and hydrogen. One another. C double bond C. Chlorine, methyl group, hydrogen and chlorine. Can you identify which is cis, which is trans? Able to get it? Dear all of you, here these are two same element. They are on the same side. Therefore, we can call this is cis isomer. Here chlorine are same element. They are on opposite side. So we can call it is trans isomer. Now let's see what's the condition here. See, here chlorine and carbon. Which one is more electronegative? We know that chlorine. Here again, chlorine. Okay. Single bonded carbon, double bonded carbon, we already studied that. Double bonded carbon is more electronegative. Carbon and hydrogen, when you consider, carbon is more electronegative. So which one you are expecting? This is the dipole moment diagram we can draw for that. Let us check it trans also. Chlorine and carbon, chlorine is more. Chlorine and carbon, chlorine is more. Okay. Here carbon and hydrogen, carbon is more. And single bonded, double bonded carbon, double bond carbon is more. Can you tell me, dear all of you, in this situation, which one having more dipole moment or which one having more polarity? Please observe all of you. Here this methyl group is contributing in this side. Hydrogen actually contribution is very less, okay? So this methyl group is contributing this direction and two chlorine are pulling in this direction. Okay, there is a resultant. There can be a resultant. Now, in this case, we can observe methyl group is in this direction. One chlorine in this direction, chlorine in this direction. See, this chlorine and chlorine are opposite, so they will be cancel each other. But this is methyl group in this direction, one hydrogen in this direction. They won't cancel, right? They won't cancel completely because the species are different. If this is methyl, this is also methyl, then they will cancel each other. But here it won't cancel each other. It having a little dipole moment, very less. Very less. Why? These two chlorine already cancel. This CH3 here, this hydrogen here. Hydrogen power is very less. Methyl power is little greater. So resultant is actually in this direction with a less magnitude. What about here? This is chlorine, this is hydrogen, and this is chlorine, this is methyl group. So CH3 giving in this direction, two chlorine are in this direction. So almost there will be a little greater dipole moment in this direction. So it having dipole moment greater. So did you see here both cis and trans isomers having a dipole moment? So we cannot confirm that always trans is zero dipole moment. Got it? That depends on the substituents which is present. But it is easy to understand such a way. What's the power of the donating power or like that? Okay. Now we are going to one of the question. Arrange the following compound in the decreasing order of dipole moment. Okay, decreasing order of dipole moment. What's that? Orthodichlorobenzene. What is orthodichlorobenzene? That's we have chlorine, chlorine, right? Orthodichlorobenzene. Next one we have metadichlorobenzene. Means chlorine, one of the other chlorine is in meta position. And we have paradichlorobenzene. That's we have chlorine and chlorine here. All right. So what do you think, dear all of you? Which one having greatest dipole moment and which one having lowest dipole moment? That's a question. See, chlorine and here it is carbon, right? This is connected to carbon. Chlorine and carbon, when you consider, chlorine is the most electronegative. Chlorine is the most electronegative. Here again chlorine. Here it's also chlorine. Here chlorine, chlorine. Can you tell me where is the dipole moments are cancelling each other? Very simple. The last one, para. Because both of the chlorine are opposite. So here dipole moment is exactly zero. Whether ortho or meta, which one having greatest polarity or dipole moment? Can you say? Dear all of you, chlorine, chlorine is almost a 60-degree angle we have. This is the resultant, no doubt. This is the resultant. Here chlorine and chlorine, let us see that it's around 120 degrees there. This is around 60, this is 120, this is 180. So here it is chlorine and chlorine. Almost it is coming to the opposite way, right? So here cancellation, here actually resultant is this direction, but almost something going to cancel. You see, they are almost going to, if it is opposite, they will cancel. They are almost coming to the opposite side. So they will be cancel each other. But here it is nearby, dipole moment is very greater. So we can say that ortho having greater, then meta, then para. So we can say decreasing order, right? So ortho greater, then meta, then para. This will be the. So in order to calculate the dipole moment of a system, as I told you, first thing we have to know the geometry of the molecule. Then we have to know which element is more electronegative. Towards that, just draw the arrow. All are similar surrounding species. If there is a chance to cancel all equal, then dipole moment is equal to 0. So the system will be non-polar. If it is not like that, we can say that it is having different dipole moment, therefore it is having a polarity. One more question. See all of you. Find the species with a maximum dipole among the following. Okay, so 4 species are given here. Which one having greatest dipole moment? That's a question. NF3. Let me draw the shape of the molecule NF3. NF3 and NH3, everything having the same geometry. NF3. Okay, this is the compound NF3. Trigonal pyramidal. Carbon dioxide, many times we discuss, it's having a linear geometry. Ammonia again having a trigonal pyramidal geometry. Okay. CH4 having a tetrahedral geometry. Okay, tetrahedral geometry. Fine. All of you, in NF3, lone pair, pulling upward. Fluorine is most electronegative, so downward. Okay. Let me just compare NF3 and NH3. Here again, lone pair upward. But nitrogen and hydrogen, when you consider, nitrogen is most electronegative, we can draw like this. When you consider NF3 and NH3, which one you think having more dipole moment? Of course, NH3, because you see all these dipole moments are adding up, resultant is upward, so it having greatest dipole moment compared to NF3. Yes or no? Because in NF3, lone pair upward, 3 fluorine downward. Resultant is downward, but still some cancellation will be there, right? Yes. So dipole moment is little lesser. Anyway, it is having dipole moment, so both are polar. But in NF3 and NH3, which one having greatest dipole moment? NH3, because all dipole moments are in the same direction, adding up. But here some cancellation, but there is a resultant. Correct. What about carbon dioxide? Oxygen this side, oxygen this side, they will cancel each other. Dipole moment is 0. CH4, dear student, I told you in tetrahedral geometry, carbon, hydrogen, when you consider carbon, carbon, carbon. If in tetrahedral geometry, all the surrounded species are equal, we studied that dipole moment is almost 0. So question, which of the following having maximum dipole moment? What is that? Definitely not second one and fourth one, because the dipole moment is 0. In NH3 and NF3 we studied NH3 having greatest dipole moment. So all of you just keep in mind, in which all system directly you can say almost the dipole moment is 0 in most cases. That is, if the structure is linear, okay, linear, if the structure having trigonal planar geometry, then tetrahedral geometry, then trigonal bipyramidal geometry, and octahedral geometry. In these kind of systems, when the surrounded species are equal or the same element, you can say that almost cases dipole moment will be 0. Let me show you once again. Linear, for example, we studied carbon dioxide. See, surrounded species are similar, mean their dipole moment will cancel each other. Trigonal planar, for example, BF3 or BCl3. Same species are there, right? All of them cancel each other, dipole moment 0. Tetrahedral, just we discussed CH4. All the species are similar, net dipole moment is 0. Trigonal bipyramidal, for example, PCl3, what we study. Trigonal bipyramidal. Here also the dipole moment for all of them will cancel each other if all the surrounded species are same. What about octahedral? For example, SF6. Octahedral is also known as square bipyramidal. In this system also, all the species, when they are equal, their dipole moment in most cases, it will be 0. So clear all of you? So actually dipole moment calculation, as I told you, nu is equal to Q into D. But we are not doing any kind of numerical here, only we are checking the resultant depends on the electronegativity of the element. The arrow we will represent where is the most electronegative element in the bonded atoms. Towards the most negative electronegative element, the arrow, and the other side less electronegative element, it will get a positive charge. If there is a lone pair on an atom, always the arrow you should write on towards the lone pair. Clear? And as I told you in the beginning part, what is the need of actually dipole moment? Dipole moment we are calculating to explain how much ionic character in a covalent compound. More the dipole moment for a compound, we can say more ionic character in the one. See, CH4, BF3, PCl5, all are actually covalent compound, but having a specific ionic character. Not this one, because here it is dipole moment 0, right? So dipole moment 0 means one more data. If the dipole moment is 0, we studied that compound is non-polar. There is no polarity or charge separation. If the compound dipole moment is having a net dipole moment, we can call the compound is polar because there is a charge separation. Alright, so if you consider diatomic molecules, suppose it is homoatomic like hydrogen. See this bond is connected to hydrogen and hydrogen. There is no change in electronegativity between these two elements. So that we cannot, can we draw an arrow towards any particular element? No. So dipole moment is 0. If suppose it's hydrogen, here it is fluorine. Fluorine is the most electronegative element. So the dipole moment, yes, there is a resultant dipole moment. There is a resultant or not. That's only we are checking. Hope you clear how to identify the compound having a dipole moment or not, or you can say that a compound is polar or non-polar. Clear all of you? So let's meet some more question. Okay, after completing all the theory, this chapter is which one? Chemical bonding and molecular structure. So we completed MO theory, dipole moment and BSc PR theory, the most expected question areas. Keep practicing question. Let's meet again with some more question and new concepts. For that, thank you all. Bye.